So here we are, another talk, this time joining microservices with serverless. Very interesting topic. Of course, you can ask the questions and rate the talk on our bot, and that's it. Enjoy the talk.
Yeah, thank you. This is the. This is weird. I'm sure this isn't. I'm not the first person who said this, but trying into my ears, and right now it looks like a movie from 1960s where they show you the future. And everyone is like headsets connected to PCs with cables and so on and so forth. That's interesting. Okay, so this is a talk about microservices and the serverless framework. Just to get your, to understand the audience a little bit, I'm going to ask a couple of questions. I just need your hands. Anyone who did anything with the serverless framework? 2, 3. Okay, cool. Anyone building microservices? Cool. For the people building microservices, what are, that's not a question, you can vote. Do you use an orchestrator? Okay, that's interesting. Do you have microservices containers in production? That makes sense. Okay, great. So let me start. What is serverless? I am very, very excited about this thing, the serverless and the functions and the microservices a little bit as well. But the idea when the cloud came out for the first time, right? You heard the word about the cloud. They always, explained it like you pay for what you use, right? That's the first description. The second is you can scale indefinitely, right? Because the cloud, depending to the vendor, for some, when it started, it was essentially scalable VMs. For others, it was, platform as a service offerings. For some, it was infrastructure as a service offerings. So the vendors had different, concepts of scalability in different layers. And depending on that, the pay-per-use wasn't actually without a commitment. So imagine you are going into the cloud and you got to have a deployment. The first thing that most of the time you need to tell the vendor is how big of a pool you need, right? They do have pricing tiers at least. If I'm going to be paying for what I use, why do we have pricing tiers? Why do you want me to select how many units I am going to use, I might be able to use, how much scaling I might need? Why do you want me to predict what my footprint will be in the cloud? And if you ever build a software as a service type of solution, you know how hard it is to come up with a pricing model. You need to protect yourself, right? There might be customers. Imagine a mailing service, right? A paid mailing service that asks you how many emails are you going to send per month. That never happened because that ecosystem, those services, they did come naturally. No one really planned for it, but it's the right and the good scalability of the platform across tenants. When you are using an Office 365 account, where you're using a Google email account, you are actually a tenant. You got an email address, you are a customer of that service, you're a tenant, and no one asks you for how much email you might send. You might send millions, you're going to pay the same amount. You might say just one per month, you will still pay the same. And in the underlying infrastructure, there is some balancing going on. Not every customer is making money for the vendor. Some of them are making very good money, but some of them are actually not the customers that we really want to have because we're losing money because of their usage. But this didn't happen with the cloud stuff because vendors wanted to protect themselves. So we ended up with a cloud where we had to tell vendors what type of scalability we need, how much of a commitment we can do. And then we could scale according to the limits that was drawn to us. The serverless thing, when we say pay-per-use, imagine, and actually it's a reality, imagine you are paying for the CPU time. You are paying for the CPU cycles you are using. You will see units like gigabyte per second. You are paying for the memory you are using every second, for a second, and then you are using for the CPU time you are using. You are paying, sorry. So that's the unit of consumption. That's the unit that you're going to be charged. So that's what I call the true cloud, because when I go out there and I have zero consumption, I'm not going to pay, and I'm going to pay only for the compute resources that I use, and I don't need to tell you any type of commitment. I don't need to tell you that, hey, I need to start with 2 servers, 2 instances first because I need some kind of a failover. I'm going to do load balancing. I don't need to. Here's my code. Make it work. Make it scale. I don't care about anything else. Just tell me how much consumption I get, the CPU time, the memory I use, and I'm going to pay for it. So that's like the dream. At least I wanted to have from the beginning. And it's happening. So there isn't, I guess, a session without a quote from Martin Fowler, right? So here's how he defines the serverless architecture. Applications that are either called backend as a service or function as a service. Function as a service is the more popular, I guess, and he uses the word container. That doesn't necessarily mean that we got a container as in the sense we understand today, but any type of isolation in the sense of container. In the future, there are I think there might be a future where a container might one-to-one map with a function, but it might be an overhead as well, because a function is much more simpler than a container. A container for me means I got dependencies I'm bringing with myself, or at least I'm aware of my dependencies. A function needs to be, higher than dependencies. What does that mean? There's a platform, your code works on it or not. That's it. You don't bring an image with yourself. You don't bring a container definition with yourself. It's just the code. It just needs to be the code. It needs to stay simple. At least that's what I think. But it looks like there might be, some services that more, converge the two and come up with the concept that you can define a function with a container and deploy with that. So these are the 3 items. I want to make sure I go through these. Sorry, worry and care just about your code. Pay-per-use metering units at maximum optimization. That means just the memory, just the CPU. No commitment, hardware provisioning. I wanted to, say, are you sure? Because some of the, vendors out there are still asking for some type of a commitment. Especially if you go with the microservices path, and if you don't have a managed service by a vendor, you are still going into the underlying layers, and you still need to manage your pool. Let's say you get 1,000 different microservices, and you are fluidly, right, orchestrating them within the pool. So what if the total amount of resources you need increases? You still need to know about it, you still need to monitor it, and you still need to scale your underlying infrastructure if it's not managed by the vendor. Does serverless equal to microservices? I know this is a little bit in conflict with the session title. It's like having a, every relationship is not a marriage is a relationship. So microservices and serverless are essentially 2 different things. When you go serverless and you are forced to build functions, you are forced to go a little bit into the microservices space as well. Because of the separation, because of the fact that a function needs to be a very small unit of working functional code, you are being pushed into the microservices world a little bit, besides the orchestration part. But what if I have, 500 functions that are all, connecting to the same database? Is that microservices? That's an open question. So it's not exactly, every function is not exactly a microservice. The size might be micro, but is it designed with what we call microservices? It depends. You might build a big behemoth, function that runs for 5 minutes. For example, on Azure, the timeout is 10 minutes for a single function. It should never happen. A function should never run for 10 minutes. But it looks like people are doing it, so they have it. So what is the serverless with this specific, icon? That's the name of the framework. And that adds a little bit more confusion, I know. The concept of serverless is one thing, and the name of the framework is serverless as well. And from this point on, we're going to talk about the serverless framework, not the concept. And the idea of this framework is to, again, that was our dream. The cloud, or any type of platform we are developing today, we always want it to be vendor-free, right? We don't want to build specific stuff for a particular platform. We want to be able to move from one platform to the other. And as you all know, cloud is kind of the biggest opportunity to vendor lock customers for these vendors. Imagine you are building an app, and it's not just about the storage. You're building a SaaS app, right, on AWS. And you're using the storage system, right? It has REST APIs, and you built the app to talk to that. Can you move that to Google Cloud Functions? Sorry, leave the functions. Can you move that to Google Cloud? Can you move that to Azure? No, because the storage APIs are different. So even with that slight storage API usage, you are actually locked into the vendor. And every day you build your app on a platform as a service offering, you are using their APIs, and you are using their services, and you are being vendor locked. It gets harder and harder to move away from that provider. So the serverless framework is trying to solve that problem. The serverless framework is trying to solve the problem of requiring to migrate a function from AWS Lambda to Google Cloud or whatever, right? And the platforms, obviously, they have additional tooling and so on and so forth. It's not just, trying. The whole framework. The only purpose isn't just to make it, vendor-free, but that's the biggest point, in my humble opinion. And these are the platforms they support today. So when you build a function, you can deploy your function to all these platforms with the same API set, with the same comments. You use the same developer tooling. You don't need to know, don't quote me on this, you don't need to know the specifics of the platform. Actually, you do, but we will talk about it. Oops. So this is how you install it. You go to, a terminal, npm install, then you call serverless login, and you're going to type in your credentials, and then you can create a new project from scratch, and you say serverless deploy, you deploy your function, and here you go, you got the URI. If it has an HTTP event trigger, if it has an HTTP endpoint, then you can trigger it through the HTTP, obviously. Not every function has to have an HTTP endpoint, but in this example it has, so you can hit it from HTTP 80. So those are the high-level comments. So let's go and start doing some stuff. Okay. I lost my mouse because I got a secondary screen. What's going on? Okay. Let me minimize this. So I do have a backup in case things doesn't work. So I'm here. Let me zoom in. Oops. Okay. So the first thing that we're going to do is to create a new project. Oops. Oops. Sorry about this. Okay. Let's make it as big as possible. Okay. So the first thing that we need to do is to create a new function. And I'm going to go here and say, here you go. Oops. Serverless create template is going to be AWS Node.js. And I'm going to just give a folder and hit enter. There we go. We created this one, and let's go in it and see what we got there. So we only have 2 files. That's it. we got the handler.js, and then we got a YAML file. Let me open up VS Code to see what we got in there. So this is the first file that you're going to need to, edit in case you want to change something. We call the service name. We give the provider, right? For this case, we're going to use the AWS provider to connect to AWS, obviously. And the runtime is going to be Node.js 6.0. So when I go down here, you're going to see that we got some additional options. And one of them is the function itself and the handler. So here I'm creating a hello function, and the handler is in the JavaScript code. So let me show you what handler.hello is, which is this handler.js file, and there we go. So this is simply putting out the whole event data plus a message out there. So obviously right now we didn't define how this function is going to be called, right? So let's go into the YAML and go down a little bit. I'm going to zoom in here. It says we can define events. So these events do differ per platform. So AWS has a different set of events that you can use to kick your functions. Azure has different events. Most of them, they go together, but the naming is a little bit different. And this is the space where you start doing some vendor-specific stuff. It's not supposed to be that way, but it is. So I'm going to comment out a couple of lines here. Oops, this one. I'm going to have events. I'm going to have an HTTP event. We will do HTTP GET, and the path, will be hello. Okay, so that's it. The function itself, I'm not going to change it. Let me open a terminal here down there. So now I'm going to deploy this thing into AWS. The first time you call this Serverless Deploy, it's going to ask you for all the credentials. Obviously, that's something I did set up prior to this session. You go ahead, you get the credentials from your management portal on AWS and bring those down here so that the runtime can talk to it. But once you do that, it's just saved locally and you can keep using it. So right now we are deploying a function with an HTTP endpoint, and I guess we got it. So let me copy this thing and hit it. So I'm going to hit this, send an HTTP request, and I got it back. Where is it? Yeah, there we go. The input is the event, and this is the message. So right now, we actually deployed an HTTP service. You can call this microservice or whatever you want it. This is a scalable, function that exists out there, and we're just going to pay for the CPU time that this function has used, and for the memory that this function has used, and obviously the bandwidth. In this case, because it has an HTTP endpoint, but that's it. You don't need to worry about anything else because we're just, outputting a simple message. But the idea is that's done. All of these worries about scalability and all that stuff is not here. So I'm going to change our function a little bit. For that, I'm going to copy some code. Let me copy it from here. Okay. This is pretty simple. What I'm doing is I'm getting the query parameters. I'm going to pass in a counter parameter and just increase it. That's it. Nothing too complex. I'm going to save this. In order to deploy this again, I can do a full deployment, or I can just deploy a single function. In order to deploy a single function, I say function, hello, and deploy it. So this makes sure you only deploy the specific function. You don't deploy the whole project if you have multiple functions. So let's go ahead and call this again. This time we are going to say counter equals 1, Go ahead. See the response. Oops. Didn't I save it? Let's go with a full deploy. Oh, it gave an error because, yeah, I said hello with W. Anyways, yeah, that was my mistake. It's really tough to, manage the mouse on a table which is not flat. It's just going down and down whenever I leave it. Okay. Come on. There we go. Let's send another request. And hopefully this time we got 2. Okay. Good. So let's do something else. I'm going to close this thing. Go to my services. I will go here. And this time I'm going to do, a deployment with another provider. Right? So I will go here and say, hey, create me template for Azure Node.js, call it, Darren's Serverless app, and create it. There we go. So this time I created a function for another vendor, and let's see what we got in this case. It's pretty much the same. So we again got the handler. Do you see the difference between the two? So let me give you some spoiler. This was another slide actually, but let me show you what I mean. So here it is. These are the handlers for the 4 platforms. I told you that it's going to be vendor free, right? It's not happening. It's very close, but it's not happening. So the handlers are different. And not just the handler. The YAML is a little bit different as well for every vendor. So you might say like, hey, what's the point of this whole presentation? This is as close as you can get. This is as close as you can get, at least right now. And that's very close. Oops. Okay. So this was the spoiler. I was supposed to show this a little bit later. So we got a function in here as well. It's just outputting the string into the body. Let me look into the YAML. This time I got the service defined, the provider is Azure, the data center is there, and there's a plugin. Serverless Azure Functions. That plugin helps with the compatibility with Azure because the Serverless Framework by default doesn't have support for it, but it comes with a plugin. So I mean, it adds that plugin down there. And then with the Azure template, what's different is this, by default it comes with an HTTP endpoint. I don't know why they did it this way, but there is an HTTP endpoint defined. It says events HTTP true. Then there is this vendor-specific setting which says authorization level is anonymous because you can have, keys for every HTTP endpoint in Azure by default. It has 3 different layers of authentication. You can have an admin key, a function-based key, or anonymous. So you need to, somehow specify that in the YAML. And then the direction. Direction is out, and the name is res. This is gonna be the parameter that we are gonna use in the function to access the response. So the name that we give here is actually the variable name that's gonna be used when you are coding the function. So right now it's res, and it's an out parameter. That means here, okay, you can actually give another parameter and say res, and that parameter will one-to-one map to the response. You don't need to go through context res if you want. So let's copy paste some code to make this a little bit more interesting as well. I'm gonna get some code from here, from my cheat sheet, and there you go. So what I'm doing here, I'm gonna do an HTTPS call to AWS Lambda from the Azure function. I'm going to send a parameter to that. Obviously, I need to copy the namespace. Let me get that here. The URI. Where is that? Oops. This is the one I need. Okay. Let's go back. There you go. I'm going to send the parameter that I get from the URI. So I'm going to send the counter to Azure Functions. It will get the counter. It will just hand it out to AWS Lambda and call an HTTP API on AWS Lambda. Lambda will increment the counter and send it back, and I will just, parse it and put it into the body. That's a lame demo, but yeah, it's just to show how it works. So let me close this one. We do have a couple of additional things that we need to do about this one before we can make it work. So let me go here and put the mouse down here so that I can write. Okay. Oops. Okay. The first thing I need to do is to go into the folder and call npm. Oh, by the way, in order to be able to use the HTTPS, I need to define it in my npm dependency list. Let me copy that one here as well. And there we go. Save it. Now I'm going to go back here and call npm install. Okay. This is just in case you want to run it locally. This same npm install command will be run by the deployment agent in Azure when we deploy our function to it. Okay, serverless deploy. So this time, oh, it's not going to work because, okay. It's going to give us an error because I didn't define the environment variables holding the credentials for my Azure account. And I can find it in my notes, which isn't good. Okay, I found it. Oh, this is going to work, sorry. This is the PowerShell session that I already defined the credentials. Okay, that's good. So right now it's creating the deployment in Azure, it's going to copy the file and so on and so forth, and we're going to have an HTTP endpoint that we can use to hit the function in Azure, and it's going to hit the one in AWS Lambda and then respond back. All of these packages that it's creating, those are under the .serverless folder in the function folder, and you can even version them, and you can even roll back to an older version of the function. And these are part of the serverless CLI. I do have the comments in the slide deck that I'm going to show. Okay, there we go. So this should be the endpoint. Let me hit that. You got it? Okay, I sent one, I got two, and that increment happened in AWS Lambda. So it looks like I deployed, functions to two different providers in a couple of minutes, and I got it running. So one other thing that you can do is to start monitoring. So let me go and say, for example, serverless, right, logs. Oh. Okay, serverless logs and the function name is a parameter. Right now I'm connecting to Azure and I got real-time telemetry coming to me. And the telemetry is actually all that you might output into the log. So as you see, there's a couple of places. It looks like there's only, yeah, okay, there's two. Here's where I log something, and here's where I log the full data into the logs, which doesn't make sense, but still. So right now I'm going to call this function, and we did connect to Azure to the log streaming service through serverless. I don't need to worry how it works with Azure or AWS. I just use the serverless framework, and then I'm going to send an HTTP request from here, and when I go back, I see the trace. So you can do some tracing, you can do some logging without worrying about the vendor, how the vendor implements it. Okay. So this is overall the full code. I just wanted to make sure it's part of the slide deck as well when you guys get it, so that you have it. So this is kind of overall the full definition of this function. If you're going to deploy it to Azure, it has the request response stuff, and the definition says it's going to have an HTTP event. In addition to that, actually you can have different events like a timer trigger, right? Let me go back and copy that one as well. Actually, let me copy the full thing. And if I go here, and so I'm going to pass there just to show it to you. This is supposed to be in the YAML file. Let me go into the YAML. And in the triggers, in the events, I'm going to say, hey, I do want to have a timer trigger. Okay? If I want to access the timer trigger through the code, the parameter name will be timer object. It will pass on to the function so that I can work with it, figure out how many times it's been run, the last execution time, so on and so forth. And then I have this cron where I define how many times the function is supposed to run. In this case, it's going to run every 5 seconds. So this is just another event besides the HTTP event. So when I hit the API through the HTTP, it's going to run. If I don't, it's going to run every 5 seconds anyway. So I am having multiple events kicking this function. You can have the same with AWS. You can have the same with all these vendors. Obviously, the events and all these triggers, they do differ per vendor. So you're going to need to look into the documentation to figure out what you exactly need to type into the YAML. And this is the AWS Lambda that I just used as a part of the demo. It has an HTTP event as well, and we hit that to increment the parameters. Real-time logging is something I already showed you, so I'm going to skip this one. And these are the additional comments that you might want to keep in mind. The serverless deploy function deploys just a single function instead of the full thing, because if you got hundreds of functions, you don't want to deploy it every time. You can invoke a function locally or remote. It depends how you set it up. You can call the serverless invoke, give him the function name, and it's going to invoke. You can actually have a test JSON file. That's a built-in functionality. If you have a test JSON file in the same folder, when you invoke the function, whatever happens to be in the test JSON file will be sent over as a test data to the function. So you can have some dummy data in the same folder to be able to simulate, instead of like me going into Fiddler and sending HTTP request. Serverless metrics, this is available as far as I know. I might be wrong about this, but this is only available for AWS. This gives you how long it took for the function to run, how many times it's been called, and so on and so forth. A couple of metrics that you can look into. And the rollback, again, this only works with AWS from what I know. You can, when you do a deployment, you can give it a version name, and then it's going to be locally saved in here. Let me show you. In this folder, like this. And from that point on, you can essentially roll back to an older version of the app if you want to. Yeah, It looks like I finished a little bit early. So, any questions? You can just raise your hand if you have a question. None? Did I do a very good job and everything was crystal clear? Okay, thank you. Yeah, thank you for being here and enjoy the rest of the conference.